In mathematics, when we go one directions, we always find a way to come back. Like for example, in operations, if we do additions, we have subtractions, multiplications, right? And we have divisions. Same thing in, you know, derivative is an operator, so we need to know how to go backward before we take in derivatives of functions. So this 3.9 is basically talk about the anti-derivatives, which is basically undoing the derivatives on this. So uh, a function f, uppercase f, is called an antiderivative of the lowercase f in a certain intervals I. That basically means uppercase f prime of x is equal to f of x in all x in an interval, right? So let's take a look at on a few derivative functions before, like we talk about the formulas of antiderivatives, and then in these sections we will only have a handful of them, and then we will be very limited to which functions we can talk about antiderivatives until we get into chapter 4. So let's take a look at on this. When we take derivative with respect to x of x to the fourth power, and we get what? 4x to the third power. Similarly, if I take derivative with respect to x of the function x to the fourth power plus 1, we also get 4x to the third power. And as so on and so forth. The next example, derivative of x, derivative with respect to x of x to the fourth power plus 2, we again get 4x to the third power. So what we saw in this three example is three different functions, but they are a family of functions. You can see that all of them is like full power, and then another one is at a constant 1, and then the third one is at a constant 2. But their derivatives happen to be all the same. So when we undo the derivatives, how do we know this 4x to the third antiderivative of 4x to the thirds go which one? So that's where this next theorem come in. The next theorem say that when you take the antiderivatives, which is undoing the derivatives, you'll be getting a general, right, which is a family of functions, antiderivative functions. You're not going to get a specific one unless we have uh, some specific values given to you. So the theorem basically say that if the uppercase f is an antiderivative functions of a lowercase f on a certain interval I, then the most general antiderivative, so that's what we're going to get, the general antiderivative of this f function, lowercase f function, that will be on that interval will be f of x plus c, where c is arbitrary constant. So we don't know, this undoing this antiderivatives will go to which, you know, antiderivative function is going to be. So therefore, we're just going to have talk about what a general antiderivative functions. So here's some a handful of formula that we can use for this particular sections, antiderivative formulas. If you have a constant time of function, if you take the antiderivative of it like before, you can basically, factor out the constant and then just take the antiderivative of the functions and then multiply it back. If you have the sum of two functions, and if you take the antiderivatives, you can basically take the derivative of each antiderivative of each functions. If you are taking antiderivative of the power functions, before we bring down the exponent and then subtract one power. So in this case, notice that here's a conditions that you need to have. Your n cannot be -1, okay? Because when you add one, that will become a problem. So when you take a derivative, you bring down the exponent and then subtract one. So we're gonna go backward. So when you do an antiderivative of this power function, basically what you do is you add the exponent by 1 and you divide it by that value, which is n plus 1. And then we know that if the function is cosine functions, right? That is basically taking derivative of sine, right? Derivative of sine is cosine. So if you want to take antiderivative of cosine function, that would be what? Going back to sine. Now remember that derivative as x respect to x of sine x is equal to cosine x. So now if we take antiderivative of this, it will go back to what? Sine. And remember, we always going to be adding, like according to the theorem, we always going to be adding a constant at the end. So once again, derivative, if you have a sine functions, and if you're taking antiderivative, that will become going to negative cosine. Because take a look at this. Before we have derivative of cosine x, that is equal to negative sine x, right? So if you are making antiderivative of sine x, this negative sign has to go to what? The other side. So basically, you are talking about negative cosine x, right? So another one will be antiderivative of secant square x. That will be tangent x. Antiderivative of secant x tangent x. That will become secant x. Now what we want to do is we want to look at the example, right? Using these antiderivative formula to do the problems. So the first example is find the antiderivatives, right? Functions of this polynomial function. So when we take the antiderivative, then this will be using uppercase notations. And since the first term, I have a power as half, so constant leave it itself, and then x to the 2, right? And then according to the formula, you basically what? Add 1 and divide by that number, which is 2 plus 1. And then minus 2 times, right? 2 times x to the 1 power. So according to the properties, that will be add 1 and you divide it by what? 1 plus 1. And then lastly, plus 6. So if it is a constant, then we know that it has what? X to the 0 power. So therefore, it will become plus 1 and then divided by 0 plus 1. So which will give us our antiderivative functions. When we simplify it, that will be 1/2 x to the 3rd power divided by 3 minus 2 times x to the 2nd divided by 2 plus 6x to the 1st power. And if you simplify a little bit further, that will become 1/6 x to the 3rd power minus x squared plus 6x. And that concludes the first example. Now, let's take a look at on the second example. So when we take the antiderivative of this function g, which is 3 cosine x minus 4 sine x. So antiderivative will be using uppercase. So g uppercase g of x, that is equal to 3 times antiderivative of cosine. We know that from here, antiderivative of cosine is what? Sine x minus antiderivative of sine x. That will be antiderivative of sine x is negative cosine x. So when I simplify it, this becomes 3 sine x plus 4 cosine x. And that concludes our part B. So part C, right, when we're taking antiderivative of these functions, what we can do first is you don't need to, we don't know how to take antiderivative of these quotients. So what we can do is we can basically simplify into something that we can take antiderivative at this point or not. So that's what we need to do, right? If you cannot simplify it, that means we don't have enough techniques. We haven't learned enough techniques to attack this kind of problem. But for this problem, so we can simplify it. So basically, when you simplify it, that will become h of x is equal to 4 secant squared x plus 2x to the 4th power minus x to the negative half power. So now what we can do is we can use the formulas, antiderivative formula to take antiderivative of it. So I want to take antiderivative of this h functions. That will be 4 times antiderivative of secant square is tangent x. So that will give me tangent x. And then plus, now what we're going to do is we're going to take antiderivative of this power function, which is going to be 2 times x to the 4th power. So when you take the antiderivatives, you add 1 to the power and divide it by that number, 4 plus 1. So it's basically going backward, right? And then minus antiderivative of x to the negative 1/2 power. So when you take antiderivative, that will be you add 1 to it and then divide it by negative 1/2 plus 1. So finally, when you simplify this, that will give me 4 tangent x plus 2 over 5x to the 5th power minus, right? And this basically become half. So when you multiply by reciprocal, it'll be 2x to the 1/2 power. And then that will be my question's answer. So far, notice that all I'm doing on all of these 3 problems, I'm not sure you notice it or not, we miss something. And that's usually what the mistakes of, student in the past that I found out. Because totally forgotten the theorems that we mentioned earlier. Right? When we're taking antiderivatives, we don't know, exact functions, antiderivative functions. So we need to write it as, a general antiderivative function by adding a constant to it. Notice that all of this 3A answer, I don't have a constant to it. So a lot of times we tend to forget, and then that is the mistake that you're going to be doing. All right, you can avoid. So making sure that you need to remember to add a constant at the end, right? When you're taking antiderivative, right away on the first step, add a constant, add a constant. So that way you will not forget. So right here again, you need to add a constant, and then you need to add a constant. Okay. And finally, right here for this problem, you need to add a constant to make it a general answer. Add a constant. So extra be careful with this, a constant, adding a constant, because usually this is what we forgot. So let's take a look at on example number D. We have the third derivatives functions. So what we want to do is we want to find out the antiderivative of that, right, over and over again. So when I take the antiderivative of the third derivative functions, then it will become the second derivative functions. And when we take the antiderivative, that will be adding 1 to the exponent and divided by that number, and then minus square root of t is a 1/2 power. So you add 1 to the exponent and divide by that number. And don't forget, lastly, you need to add a constant c. So simplifying this, that will help us to get 1/2 t squared minus, this is going to be 3 over 2, so it will become a 2 over 3 t to the 3/2 power plus a constant. And if I take antiderivative of this second derivative functions, we will be getting the first derivative functions. So when I take antiderivative of these functions, that will be t squared. You add 1 to it and divide by that number, t plus 1, and then minus 2/3 t to the 3/2 power, and then once again add 1 to it and divide by 3/2 plus 1, and then plus, so this c is basically what will have t to the 0 power. So you add 1 to exponent 1 and divide by 0 plus 1, and then don't forget to add another constant d. So when you simplify this, right, that will help us to get, this will be 1/3. 1/3 times 1/2 is 1/6 t to the 3rd power minus, and when you simplify this part, that will become 5/2. Right? When you multiply by reciprocal, that will become a 4 over 15 t to the 5/2 power, and then plus, this will be c times t plus d. And finally, if you take antiderivative of these functions, then we will get f of t function. So let's try this problem, okay? So when we take the antiderivative of this first term, I add the exponent by 1 and divide by 3, right? 3 plus 1. So when I simplify it, that will become 1 over 24 t to the 4th power. And similarly, on the next term, I add a 1 to the exponents and divide by that number, 5/2 plus 1. And when you simplify this, that will become 8 over 105 and then t to the 7 half power. And on the third terms, when I add 1 to the exponent and then divide by that number, which is 1 plus 1 is 2, I got c divided by 2 t squared. And lastly, the fourth term will be dt, and then the fifth term is a constant e by itself. And conclude this example number 4. So as you can see in example 1, four examples, because we don't have a specific conditions of the antiderivative functions, all we can do is write it down in terms of a general antiderivative functions by adding a constant at the end. So for this example 2, it's given to you the first derivative functions, and then we have a specific information for the original functions. So as you can see that right here, f of 1 is equal to 2. So this will allow us to get rid of that constant c and then get a specific value instead of a general antiderivative function. So let's try to do this problem. So f prime of x, let's simplify a little bit, x and then times with 1/2, so x to the 3/2 power. That's what we get. So when you take the antiderivative functions, that will be f of x, which is going to become, you add the exponent by 1, right? And then you bring down this power, and then add a constant c. So this will give us, this will be 5/2, so it will be 2/5 x to the 5/2 power plus a constant. So now this is basically a general antiderivative function. But since we know that, right, since we know f of 1 is equal to 2 with that given, then I can basically find out, right, that basically help us to find out what is the value of c is going to be. So that basically tell, we're going to substitute this value into there. So when I substitute, for x is 1 into this functions, so my function value will be 2. So this gives us 2 is equal to 2 over 5, 1 to the 5/2 power plus c. So this gives us the value of c, right? So it'll be 2 equal to 2/5, 2 over 5 plus c. So therefore my c is equal to 8 over 5. So now I can basically get my specific functions satisfying this condition. F of 1 is equal to 2. That'll be this 2/5 x to the 5/2 power plus 8 over 5. That is my answer for this question. So similarly, for example 3, we want to find out the f functions. The given is f double prime, the second derivative functions. Since this is the second derivative functions, we need to take antiderivative twice in order to get the f functions. So when we're taking antiderivative twice, that means we're going to have two constants that we will not know. So that's the reason why in here it's giving to you two specific informations allow us to find those values. So let's take a first antiderivatives on this part. So first I rewrite this 3 over square root of x into x to the negative 1/2 power. And then when we take the antiderivative, we add 1 to the exponent and divide it by the number. And then don't forget to add constant c. So when I simplify the denominator, that will be 1/2 and multiply by reciprocal, that becomes 6. So in order to find out, this value c on the first derivative function, because this is the general first derivative functions, and we have one information that tell us what the first derivatives is evaluating at 4, that will be equal to 7. So therefore, what we can do is we can substitute 4 for x in this first derivative function, and then we will get the function value 7. So that way we can find out what is our c is. So by plugging in this informations, So my first derivative function is 7. That will be equal to what? 6 instead of x, we are substituting what? 4, right? To the 1/2 power plus c. So this is basically 7 equal to 12 plus c. So therefore my c is equal to -5. So now that gives us my complete first derivative functions, which is f of x is equal to 6x to the 1/2 power minus 5. Now, let's take the antiderivative of this functions, first derivative functions, to get our function f. So when we take the first derivative function, antiderivative for the first derivative functions, right? So we can add 1 to the exponent 1/2 and divide it by 1/2 plus 1. And 5, that's basically talking about 5 times x to the 0 power. So we add 1 to the exponent and divide it by 0 plus 1 exponent. And plus adding a constant d at the end. Okay? So when you simplify this, that will become 4x to the 3/2 power minus 5x plus a constant d. From the second information that we haven't used yet, right? Another information we haven't used yet, which is like f of 4 is equal to 20. That means the function f, evaluating f4, our function value will be 20. So that will allow us to find out what is the constant d that we need for this f function is going to be. So when you substitute x for 4, my function value will be 20. So function value is 20. Okay? That is equal to 4 times 4 to the 3/2 power minus 5 times 4 and then plus d. So when you simplify, that will be 20 is equal to square root of 4 is 2. 2 to the 3rd power is 8. 8 times 4 is 32 minus 20 plus d. So this will give me my d. So my d, that will be equal to 12 subtracting 12 on both sides, which is going to be 8. So finally, that'll help us to get our function, the desired function f, with satisfying these both conditions, which will be equal to f of x is equal to 4x to the 3/2 power minus 5x plus 8. And this concludes this example and as well as this sections.